Okay, good morning and good evening, everyone. This is Rakesh here. Just confirm if you can see my screen. All right, thank you. So we will continue with the integrated transformations today. All right, thanks. All right, so just in case if you have any questions, please let me know. I'll be glad to answer them. If not, we'll continue with data integrated transformations. All right, so integrated transformations are an additional set that will allow us to do some additional activities other than the platform, but platform or the basic transformation set that will allow us to actually start working on a data migration project. So if you want some additional activities like change data captures, right, or some performance fine-tuning activity, or some sort of Excel activities like transpose and reverse transpose, right? So in those cases, you can use the integrated transformations, but most of the work that you do will be from the platform transformations. So if you look at the platform integrated transformations, the first one is data transfer transformation, right? So if you look at this description, it says allows a data flow to split its sub-process into two sub-data flows and push down resource-consuming operations to the database server. So it says about two things. One is splitting a data flow into two subparts. If you just look at the definition, so it says splitting the data flow into two subparts and pushing down the resource consuming operations to the database level. So two activities. So just keep in mind, even when we design a code, it should be quite good enough that it should handle the performance tuning activities as we develop it. So there should not be any additional space for us to go and review that work, right? So let us say I have a data flow with a couple of transformations in it, and this is my source table connected to my transformations, and from here it's connected to my target table. Now if you look at this one, so let us say the source has some good number of records, 10,000 records, and here the first one I'm trying to do a group by, and here in the second one I'm trying to do a lookup onto a table which has somewhere around another 10,000 records. So if you look at the background activity, what will happen? So when I run this job, all these 10,000 records are first pushed onto the system cache, right? So this star is our system cache. So whenever you design a code, just keep this in mind that this is how it will work. So we can efficiently design the code, right? So just think in these lines and understand if our, design will have an impact with this or will not have an impact with this based on the volume of data and the complexity of the work that we are doing within a data flow. So now if you look at this, all these 10,000 records are pushed onto your system cache. And now it is trying to do a group by in the first query transformation. So when I do a group by, 10,000 into 10,000 minus 1 iterations happen within my system cache. So first set is 10,000 into 10,000 minus 1. Right, so because when you try to do a group by, first record will compare with all the remaining, second with all the remaining, third with all the remaining, and if they find their identical records, they will try to bind them into a group. Now 10,000, right, so number of records that are present in the cache are 10,000 and 10,000 into 10,000 minus 1 plus one more thing, you're trying to do a lookup. So the data is still in the cache and you're trying to do a lookup. So 10,000 records will be compared with another 10,000 records. So I was talking about it quite often in our session. We've been talking about this, so just understand that this is more important. So at a time when you just execute a table with 10,000 records, 10,000 records is quite minimal. But if you execute that, these many records will be there in your system cache. So first initial 10,000, then the 10,000 into 10,000 minus 1 iterations and their output, plus 10,000 into 10,000 when you do a lookup and their output, plus the records that needs to be pushed onto the target table, right? So huge data volume will get pushed onto your system cache. Now you decide if you do this activity in two sub data flows, right? Two data flows. So you do this in one data flow, push it into one target table and take the target table as source here in the second data flow and do a lookup and push that. Then obviously whenever you use a target table here, so the system cache will get flushed out, right? So all the cache that you are using here will get flushed out into the table. So your cache is freed. Again, that table will become a source here. Again, reuse and do a lookup and free it. So you are not occupying the system cache continuously. You are freeing the system cache twice in this process. So when you are developing a job, keep this kind of things in your mind. But if you are doing a support activity, and let us say somebody has already built this job, right? This data flow is available, which is running for a longer period. Now they ask you to fine tune this, right? So first thing that you need to do is go and look at the execution time, right? We'll see that from the management console, how to look at the execution time of a data flow. So we will go and see the subsequent executions. What is the time taken for this specific data flow? And next thing, we will go and see the data flow. If everything is good, if any time and resource consuming activities are present on the system. If not, we will go and use a data transfer to improve the performance, right? So this one, first thing what, it splits the data flow into two sub data flows, and this will not allow the system to consume the resources, but it will do a push down operation onto the database. So whenever I'm trying to do a group by and all this thing, so all these things will be flushed onto my desktop, and my desktop will become my source, not my system cache. So in this case, you are not using the system cache, you are using the persistent cache, and you are trying to improve the performance of your jobs. All right, hope you got this point, right? So whenever you are building this job by using a data transfer transformation right here, so it will split your data flow into two subparts. So prior to this transformation and after to this transformation. So once this gets executed, all the data that is present in the cache gets flushed onto your system drive, and from there that will become an input to the subsequent data flow, this next sub data flow, and this file will be deleted, and now this goes and sits in the system cache, right? And from there the lookup operation is done, and then it is directly loaded into the target. Again, the system cache is flushed. So in the same data flow, without doing any changes, you're trying to flush the system cache twice. So let's create a job. I'm calling it as DT for data transfer, DFDT. Select a table from your source data store and make it as a source table. Right, as per our example, first one is qt underscore group by. Go to the group by tab, select all the columns here, then drag and drop them into your group by tab. At the same time, move them to your output as well. Right, so group by is done, and next one is lookup. So earlier, if you remember, we did a lookup using a validation transformation, right? Exists in the table is the option that we selected to do a lookup. Now let us look at how can we create a lookup using a query transform, right? So my first condition is to do a group by, and the second condition is to do a lookup from this table to this table. And if the order IDs I have in my source are present in my details table, then it is a valid entry. If not, it is not a valid entry. So what I will do, I will try to look up my order ID on this table, right? Orders table to the order ID on the order details table. All right. So first thing is you do that lookup activity in the mapping tab of a query transformation. So comment the existing one. You can delete that one as well, but just in case if you want to comment the other part of the code and do a direct mapping just to do some testing, so it will be useful. So just I commented this one here, and now go to the functions and go to lookup functions, lookup ext, and click on next. So lookup ext is a function that will allow us to do a lookup on some other database table and see if our data is present in there or not. And also you can do some additional activities here. So first you need to pick the table, lookup table, click on the drop down and go to the data store where your table is present and click on OK. Now in the input schema you'll see our orders table, and also on the lookup table you'll see our order details table. So now my comparison should be this ID is equal to this ID, right? So on a general business node, you can say this ID is equal to that ID. This is the comparison, but you can also do additional activities here. So condition here is column in the lookup table is order ID. If you click on this drop down, it will show you all the columns in the lookup table which you can use in your condition here. Then operations, you can see any of these operations, right? Is equal to, is less than or equal to, greater than or equal to, not equal to, right? Is null or is not null. So here our condition is equal to some other column. So here you cannot do a drop down, so you need to select from here and drag and drop it. Right, you need to drag and drop it into this expressions, right? So now the column in the lookup table order ID is equal to the group by order ID, which is my source table here. So if this is equal to this, then output, you get the order ID. If it is present, then only return; if not, return a null value. So this is what I am trying to write here. Right. You also can do one more additional activity, saying that you can do a lookup and you can get additional fields from the other table. Right. You can say I need product ID. Right. I need unit price. You can get these values. So we also have some other scenario where we will be looking at that. So if you want to delete that, you can select that and delete rows. Right. So as of now, let it be for order ID. We also have a new function call to look at. So we will look at that new function call and we will call the other values, right? So now as of now, we are just trying to do a lookup, right? So I compared my order ID with the order ID in the table, and I'm getting the order ID from my lookup table. And if it is not equal to this, which means it should return a null value. So just click on finish. And you will see this lookup function available here. So remember I was telling you that in the version 3.0, the main drawbacks of 3.0 were if you write a function like this, there was no option to edit this function, right? So we from 3.2 we have these options to edit. So if you select the function and do a right click, or you can just select the function name here and do a right click, and you will get modify function call. So if you click on modify function call, it will again take you back to this window. So this is the option that is not available in data services 3.0. From 3.2 this one is available, so you can stress this on your interviews, just to make sure that the other person understands more, that you worked on different versions of data services, right? So you can stress on this one. So modify function call is one more option that we have. And if you look at the further options that they are there, cache specification. So what kind of cache? So demand load cache, preload cache, or no cache. So these are the three mechanisms in which the cache is requested for this activity. One is no cache, especially when there is less volume of data, you can go for no cache. And preload cache, the cache is available and it will just get loaded into that and it will go and work. And demand load cache is the cache utilization will be calculated, and based on that required space, so on demand it will be requested. So by default it will be preload cache. And these things you need to change unless and until there are huge volume of records. So normal data, there's no need for you to go with these changes. Right, run as a separate process. So run as a separate process. So when I'm doing a run as a separate process, the backend threads, right, it will go and get executed as a separate process. That will improve the performance of my job, right? So column in the lookup table. So you can also do a sort on the data by a particular column in a lookup table, right? You can do this one. And return policy, maximum, minimum, right? So when you are returning the values through this function, so what does a function do? The basic definition that we read in books, function always returns a value. So when you give input to a function, it returns a value, and this policy, return policy, will give you what you say, the maximum or minimum of that. Then you have a custom SQL button here. So if you want to do more than what your uh, lookup ext is doing, right? So if you are trying to do more than lookup ext, so there is a possibility. I'll give you an explanation here. So just in case if your order ID is so there is some order ID which is 1000, which you don't want to keep it there. So what we can do is we can write a decode statement. If your order ID is equal to, since it is an integer, 1000, you can do a lookup, else you can get the order ID direct from the source. So if it is 1000, then only go and get a lookup, or if it is of type A, you go and get a data, do a lookup. If it is of other types, there is no need for you. So you can do a custom function on top of this custom SQL. So this custom SQL, if you require this, but my suggestion, break it into 2-3 steps and do it. No need to do it on one single place. Right. So this is how my order ID works, my lookup works, lookup ext. So you can create a function by going to select the column on the schema out, mapping tab, functions, and here lookup functions in here. You have lookup ext, select that and click on next. You'll go into this window, and here you'll select the table, then the column from source and target, which means my lookup and my source table, and the column which it needs to return, and just click on finish. And if you want to modify this, now just take a step back and create a target table. Save it in your target data store and click on OK. Now validate this to check syntax error. So I'm not going to rerun this one because we already knew that this is going to take more space on the system, and again this activity will take more space on the system. So this transformation, data transfer, you utilize especially when you are having huge volume of data. So keep that in mind. Even your source tables and lookup tables has greater volume of data, you'll go for this data transfer. So pull in the data transfer transformation, break the job in the middle, and pull in the data transfer transformation. Now if you do this activity, so our data flow name is df_dt, and this is the only one data flow that is present. But after you added this one, once you execute your job, so this portion of the job will be executed as df_dt_1, and this portion of the job will be executed as df_dt_2. And this data transfer transformation will push down the resource consuming activities, like all the group bys and everything will be pushed down to your there are two spaces in which you can push it down. So based on your option, it will go and do a push down operation. Now if you look at this, this is the schema that is coming as an input and output. So there's no input and output schema. So if you want to remove this in the future, right, you can just uncheck this, and system will just ignore this transformation's presence, and it will directly go to this one. Now if you want to keep this transformation, there are three mechanisms in which the transfer type happens. One is automatic. You choose this, you ask the system to choose between table and file. So when I select file, my file options is activated, and when I select my table options is activated. I'll show you by selecting file. So when I select a file, so what will happen? My entire system cache is flushed onto a file on my drive. So I'm just giving you a desktop to show you how this works. And also I'm giving a unique name so that we can easily identify that. So when I execute my job, this data goes into the cache. So group by is done. Now the entire data in the cache is pushed onto this flat file 1234567.8.txt, and that file is created on the desktop, and this system cache is cleared. Now that file will become an input for this, and the lookup is done on the system cache, and again it is written into the target table, and that system cache gets flushed. So now let me execute this. I have to show you two things. One is your file getting created and deleted. So once the job is done, this file gets deleted. See, now you see this file, it got generated and it's deleted automatically, right? So this file gets generated when your cache is dumped onto your persistent cache, and then this file gets deleted automatically once the job is successfully done, which means your job is successfully completed. Now if you look at the log, so this job started, data flow started. Now you see the sub data flows. So technically speaking, we did not create any sub data flows here. All we have is df underscore dt, but if you look at this, df underscore dt underscore 1 and then df underscore dt underscore 2. So it breaks a single flow into two sub flows, execute the first one and then the second one, and then it achieves the complete operation. So this improves the performance of your jobs, right? It reduces the runtime because the cache is freed, twice in this job, twice in this data flow. The second option that you have here is table. So though you select a table or a file, please do not uh, select an existing table name or existing file name, because this will drop and recreate the table. So it will first create the table. If the table is already there, it will drop and recreate initially, and then it will load the system cache data into that one, and then once the job is done, it will go and delete it. So you will, if in case you give an existing table name, there are possibilities that you will lose the data. I lost it in the initial days, so a lesson learned I'm trying to share with you. And again, you have the preload caches and postload commands like you have in your query transformation, right? The moment you select a file, you will not have anything, right? But the moment you select a table, right? So you have your start routines and end routines kind of an activities, right? Loading options, how many loaders you can, say to the target table. You can do an append mode or truncate and reload mode, right? So this options will be there for your tables. So now if I do a run here, so a table called new table will be created in the database and it will be deleted. Just give me a second, I'll be back. Right. So any questions on this data transfer transformation, please let me know.
Hey Rakesh.
Hey Zafar.
Hey, how are you?
I'm good. How are you?
I'm good. I'm good. The data transfer can be used with the platform transfer as well, or uh, because
Yeah.
it good for the performance, right? If there is something like we are dealing with the big source table, then we can use data transfer in the query transform.
Yeah, I mean, you can use it as a combination with any other transformations that are there in data services, wherever you feel that. So let us say a good example for this one is you're working on a support project, right, where you need to uh, do some defect fixing and also some performance tuning activity.
Okay,
So when you are working,
it's not specific to lookup tables, right? Data transfer can be used for any kind of
any
transform.
any any transformations, it's not just specific to lookup. So if you are trying to do a bulk operation, a more than one operations or complex operations within a data flow, so what we see on the screen right now, so this entire stuff will go and sit in your system cache. So if you see that lot many complex operations are happening in this one, you can split that into two by using your data transfer transformation. So whatever we have in data flow is will matter, and that too,
So
especially when you have huge volume of data. Sorry, go ahead, Zafar.
yeah, can we use more than one data transfer in a one job?
You can use in a job, but use it in a data flow. Actually, technically, you'll use it in a data flow. So if you see a more complex data flow, so there are like some more 6 query transformations that are present. You can split that into sub parts. You can have one more data transfer here,
Okay.
some transformations, and
For
so on.
example, in this job we have two query transform. That's why you are splitting with the data transfer, right? So
Yeah.
for example, if there are three or four query transform, so we can go with another data transfer, right?
Yeah, we can go, but we also should see the need of having it, because if you look at this one, so
Mhm.
I'm just assuming how much system space it is going to utilize
Oh,
and what will be the complexity. If I
okay.
feel that, okay, so my job is running for, total job is running for 3 minutes, and in
Okay.
that, only this data flow is running for 2 minutes. Now these people will go and ask me to reduce this execution time. The simplest thing that I can do is I can go and look. I have multiple
Okay. So
transformations.
it doesn't depend upon the query transform. Actually, it depend upon the resources taking, right? So then you will decide.
Exactly. Exactly.
Okay. I have one more question. I'm a little
Yeah.
confused for the lookup. So can you little explain again, because you are doing the lookup for the orders table.
hmm
So you are doing the same thing for lookup with the same table. So I'm a little confused. Can you
So
explain?
yeah. So when I do a lookup, this is my source table, right? The orders table is my source, and I'm trying to do a lookup on the order details. So my requirement is if my order ID here is present in this table, then it is a valid entry. If my order ID here is not present in this table, this function will return a null value. So this is what I'm trying to do. So I'll just redo this for you.
Give me 1 second. Okay, so there are two different tables, not the same.
Yeah,
One is
two different
order and the
tables.
second was order detail. Oh, I
Yeah.
thought maybe you are doing the same. Okay, so you are checking in the orders, right?
Yeah, so I'm checking from orders to order details, right? This is my lookup table. So lookup table is always my the other table, order details table, not my source. So here I have my lookup table, which is order details, and my input schema, which is my orders table. So now what I will do, the column in the orders lookup table, which is order details, is equal to my column value in the input table, then get the column value from the order. If it is equal, then return that. If it is not equal, specify a default value null for this, and you are just clicking on finish. So this is my lookup. I compare from this table to this table, and if the entries in this table are present in this table, I get that output, or if it is not present, then I will return a null value for that. Is that clear, Zafar?
Okay, so you are checking. Yes, so you are checking from orders, right? If in order detail, we have all the transaction, right? So you are
Yeah.
looking up in the orders table, or which table
From
you are
this
looking?
table, so just let us take this as my source and this as my lookup. So I'm trying to look my data from my source. If it is present in my lookup table, then I'm considering it as my right entry. So for example, let us say my orders table has unit of measure, right? And
Mhm.
I have another lookup table called LKP underscore UOM, unit of measure. Now what I will do, this orders table has some 10, 20,000 entries in this one, which has a specific unit of measure mentioned for that. And I cannot go and look at these 20,000 records and judge that, okay, all these 20,000 records has a valid unit of measure. I cannot go and do that manually. So what I will do is I'll process these records to a lookup table, just like our SAPT tables, which has a valid entry in that one, right? These tables can get corrupted because the end users can enter any wrong data, or they can misplace the data from the front end application. But these tables, the T tables or lookup tables, are the tables that are cross-checked and verified, and these tables will have the standard information. So I will compare my unit of measures column with the values in this column, and if it is present, then it is a valid entry, and if it is not present in this table, then it is my invalid entry. So instead of returning the wrong value, I want it to be converted to a null, right? So instead of returning a wrong value, I want it to be converted to a null, a default value. So that is what I'm trying to do.
Okay. So you basically are trying to find out the valid order ID from the order detail table, right? Then,
Exactly.
okay. So we can do anything like with the other tables, for example, if you want to check, right? For example, if there's a material ID, then we can check in the material detail table as well, right?
Yeah, yeah, you can go and do that. So, for example, you have the material types, right? The raw materials that are used, or semi-furnished, furnished material. So you can go and look up that table on some other T table, like currency, this thing, T005. You have this T005 table as currency table, right? So you can you can cross-check your input currencies onto that table and see if they are valid inputs or not. So the reason why we need to do this is, the end users might key in some wrong entry into your system. So that is the reason why we do a validation as well. I gave you the same example when we are talking about the validation transformation. The end user must, sometimes might go and do a wrong entry. And since it is a varchar, the system will take that one, but it should be a valid entry. So if it is a valid entry or not, we compare that using a lookup. So we do a comparison onto some other table which has a standard list of values, and then if our input is present in that one, so it is correct. So now we are not doing anything manually. We are pointing our input data to that table, and we are asking the job to compare it. So if it is there, it is correct. If it is not there, then it is wrong.
Mm. Okay. So the validation and the lookup, they are not similar. They are different, right? So we can
They
use
are
the.
different. See, you can do a lookup from validation. You can do a lookup from query transformation. The validation will return valid and invalid tables. So you need to judge where and when you need these transformations, right? So if you just want to look up onto a table and get some other value, or just look up onto a table and if the value is existing, it should be passed, then you can use a query transformation. But you want to do a lookup and you want to catch the values that are not there in a separate table, then you go with the validation transformation. This is a scenario, like where and when you need it, you go and you apply it.
Okay. I have to look at this one lookup, but it's still I'm confused. Maybe I will read some documents.
Uh, no, Zafar. Let me try to explain. So lookup is
Maybe if you,
confusing or
yeah.
validation is confusing. Which one is confusing?
I think validation is okay because you showed yesterday, like when we are doing the validation, we can do it, right?
Yeah,
If it's valid, we transfer into different table. If it's invalid, then we transfer in that other
yeah.
table. But
So
at
there
the
are three
lookup,
types of validations that we are doing. In the validation, we are doing three types of validation. One is format mandatory, and the third one is lookup. So when I'm doing a lookup validation, so what it will do, I'll just try to explain this because these are pretty much important. We can spend more time on this. So if I pass my data, my source data through a validation transformation, so this validation transformation will have a lookup table, right? So what it will do, it will try to, if you're trying to do a lookup validation, it will try to compare your input record. So we will be doing a validation, lookup validation on a single column. So it will go and
so
check if this single column,
right now, are you explaining about the validation or the lookup? Is a lookup, right?
yeah, it's both. See,
Okay.
lookup is an activity that you can either do it in a validation or you can do it in a query transform.
Okay.
So I'll just
So
show you what
you're
will be the
explaining both.
difference. Yeah,
Okay.
I'll explain both and I'll show you what will be the difference if I go and do it in a transformation, validation transformation, or if I use a query transformation.
Okay. Okay.
Okay. Right. So now, using a lookup, we do a comparison, right? So on a particular column. So I look up onto that table and see if my values are present. So let us say this column that I have here is unit of measure, and this is my T table for unit of measure. So it has multiple records here. So what it will do, my job when I do it using a validation transformation, it compares my input record with this particular record. So one by one, my first record with all the records, my second record with all the records, my third record or third value in that column with all the values and so on. And then if it finds it in this table, let us say if I have a record A here and A is present, then this goes to my valid table. So this is validation transformation. Invalid, right? So A is present in the table. Now A goes to this table. Now let us say there is another value called B as a unit of measure. It will go and compare it with this table and B is not present. The next value that we have here is C. So what it will do, B is not present, so it will push it to my invalid table because it is not present there. The next value that we have here is C. C is already present. Then it goes to the valid table. So lookup is an activity that you are doing using a validation transformation in which you can capture the invalid records into a table, right? So this is what we do using a validation transformation. So if I do the same lookup using a query transformation, I'll show you the difference now. So when I do the same activity using my query transformation, so I don't get the okay, so let's be that. So when I do the same thing using my query transformation, now it is not my validation, it is my query transform. So when I want to do that using a query transform, I use a function called lookup underscore ext. So this is an activity that I'm using, performing using a query transform. So again, I compare my source record with my this thing. It goes to my target table. B is compared here. B is not present. So what you get? You get null for that particular row. Then C is compared. C is present there. It will go there. And again, let us say if D is present in the source, but it is not present in your lookup table, then again for that row, it will return a null value. Alright, so this is how your query transformation works. The invalid values are pushed onto the target table. So for query, there will be no valid and invalid table. It will be only one single table, that is your target table. And in the target table, if the value is present in the lookup table, it will be displayed here. And if the value is not present in the lookup table, it will be replaced with null. So is that clear, Zafar?
Yeah, it's good. Yeah.
Yeah,
Yeah.
thanks, man. So next, some useless transformations are there. Date generation, effective date, and so these two, not much of use, but if we get a scenario, we can utilize them. So after that, we have good transformations, really interesting transformations. We'll look into those scenarios as well. Now let us look at the date generation transformation. So if you look at this, it says produces a series of date incremented that you specify. So let us say if I want an incrementation by day, incrementation by week, and incrementation by month. I can go and create that date. So in my previous batches, I have one of my student from NBA USA. So he gave me a good example that he kind of did a similar activity where using a date generation transformation. Sorry, the output of the date generation transformation is a series of dates that we produce with a start date and end date that you specify. So with this, we can do a projection, future projection forecast, right? So I can say this will be my first week of the quarter, second week of the quarter, third week of this quarter, and so on. And per week, we can do a projection, a forecast analysis. So if you are trying to do some forecast analysis and all these activities, you can use this date generation. So I'm creating a new job underscore date underscore gen, and this is my source transformation. So if you pull in a date generation, this is your source transformation. So the reason initially why I got confused with this transformation, or why I could not find a relevant one, is I always thought since it is a source, at least there will be one source table as a combination. Now how can I join this column to this one? So that was my confusion. But yeah, so this one is used to project a future analysis. So if you open this date generation transformation, so it will give you a start date. So click on the drop down and select the columns here. So 1st of May, right? And click on OK. And end date, again click on the drop down and select the date. So you can say end of June and click on OK. Incremental mechanism is by daily, monthly, weekly. So I'll go by daily. And if you want to utilize the cache, you can check this box, and join ranks, we already spoke about it. So if I just simply execute this, the query transformation is also not required. I can just map it directly to my target table, but I have something else to teach on this one. So I just used a query transformation. So if I execute this one, what will be my output? My output will be a date column in the target table which has value till end of June. Starting from 1st of May till end of June, I'll have the values. So 1st of May till 30th of June. So I can create this projected column, right? Weekly, monthly, and with daily incremental mechanism. Now, let us look at the date functions that are present in data services. So let us say which week of this month is this one. So new output column, insert below, week, integer, then day in the year, which day is that? Month, which month is that? And year, which year is that? Then, so let us say this is my day of week. Then new output column, day in year. So which day in year is that? So there are, multiple date functions. So concatenate date and time, date difference between, so day in month, day in week, day in year, physical day, is weekend or not, Julian, last day of the month, last date, so quarter, system date, system time, week in month, and week in year and year. So these are the built-in functions on date. So we can utilize these. So week in month, week in year, right. So now I created multiple output columns with that data type as integer. Now here I go to this mapping tab, I select the column and go to the mapping tab and just type week. So you get these functions. The first one is week in year. So you just type it and just call this date into this function. So this function will take the input of this date and it will generate an output. So it will give you first which week in the year. Then I can just copy this rather than dragging and dropping it. I can just copy this. And then this is week in month. I can just paste the values. Okay.
Extra bracket.
Yep, got it. So next one is day in month, day in week, day in year. You can pick anything, day in week here. So, right, then month of. So there are different month functions as well. You want to check, right? No, only one month, which will return the month of that, the state in which month it is present. Then the year of this one. So especially for insurance companies, if they want to pick a specific discount for last year or next year, so you can just go and do this activity by specifying in which year, which day. So based on your requirement, you can split this date into different values and you can do the calculation. So you can also do a quarter, which quarter are you present in. So now I created some new output columns and populated them with functions, right? So validate this current to see if there are any errors. No errors found. Execute this one. Now the job is successfully done. If you go and click on this table, now it says this is my 18th week in the year, right? And this is the first week in the month, and this is day 5 of the week, right? Days 6 and 7 are Saturday and Sunday. Again, it goes with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Right, this will be the weekend. And which month is that? This is 5th month, and since we took data for 2 months, so we have 5 and 6. Here is 2015 and day and year. So, so today is 5/5/2012, 2015. So today is 125th day in the year, right? So you can get all these calculations out. So a simple transformation which can be used as your source, and you can do a future forecast analysis. So you can project a target future date, and with that you can go and do some calculations, assumptions, analysis, or forecast on that one. Alright, so next one that we have here is an effective date. So what is an effective date? So when you're trying to do some operation, let me put it in a very simple way. I'm buying petrol, right? So a gallon petrol, let us say it is $40 last month. And, previous to that, it was $35. Right, so previous month it was $35. So there will be a time span from when it started to become 35, and earlier to that it can be $32. So there is a time frame from to date till so and so date, it is $35, and after that it goes changed to $40. So I have data like this. Fuel, price, and date. So if I have this fuel, petrol, and price is initially it is $38 or $35, and let us say 1st of May it is $35. Now the same petrol is become $38 by 25th of May. Alright, so now the same petrol has become $40 by let us say 25th of June. Now if I want to write it in a different way, so you can write it like this. Petrol price $35 from a particular start date. Prior to that it should have a start date. So it will have from and to, effective to date. Right, so based on the data. So what will be the to date here? 24/5/2015. You can have the same day or one day prior to that. So this is my to date. So let us say it is some XYZ. Next, I have the petrol. So now it's $38, and what is the start date for $38? So 25/5/15, and its end date is 24/6/15. You got what I'm trying to say? I'm trying to calculate an effective 2 column based on my data that is present in a single column, right? So this you can achieve using an effective 2 transformation. Right, so we don't have a right data set for this, but if you are trying to do an effective date transformation, keep this in mind that your source table should have a date column in that one, which is relevant to a particular column. So like the one we saw in the Excel, the price is relevant to start date. I mean the date column when it is getting affected. But if you want to calculate a start date and end date out of it, then this price is directly proportional, or this price is a column that get affected when the date changes, right? So I'm calling it as EDT, effective date generation. Now let us go and look at the orders table. So I have some order date, right? Just a random column I'm using it. So not a real-time scenario, but you just looking at this one. So now you go to the transformations and pick the effective date transformation, connect it with your source. Now if you open the effective date transformation, this is how it looks. So you have your schema in, schema out, and effective date column. So which is your date column? So let me go and pick it. The required date. So if my required date is changed, right? So what is going to get affected? So the one like my date, the value in my date column changes in the Excel example that we spoke. The value in my date column changes. The price in dollars for my petrol is getting changed. So what is the column that gets affected? So let us say I'm just taking some random column here, right? Right, so this will be an effective 2 column that will be created. So this will have the date until which the previous value is there. So if you look at this one, the date until which the record is effective. So it is automatically generated by the effective date generation transformation, and its data type is date. So this is an automatically generated column which will capture based on the data that we saw in the Excel. To forget about these orders and order detail tables. So based on the data that we saw in the Excel table, so I need to pass in the date column here and the price of the petrol here, and this column will be generated, and this column will give us a valid and date and start date. So if you don't have any date, right, effective to date value, so this will be the system default date. So you can pass a global variable here and give a default date. So let us go and connect it to a target table and connect it with this and validate this. No errors found. Now let's go and execute this one. So this is successfully done, and if you go and look at the target table, it will go and create a new output column, but we don't have relevant data here. So that's the reason why it is throwing some error. So if you have a relevant data, it's not even throwing an error. It is showing the last date, the default date that we specified in the system. But if this one is having some relevant data like the one we saw in the Excel, so it will pick the start date for that, and effective 2 column will be the end date, from when and when it is that $5, from when and when it is $40, from when and when till when it is $60. So you can pick all those 2 dates here using this effective date transformation. Right, the next one we have here are hierarchy flattening, history preserving, key generation, maps, etc. So let us talk about pivot and reverse pivot. We'll talk about these transformations in the next session because I need to just create some rough notes for this. So I'll show it to you on that one. So let us go and look at the pivot and reverse pivot transformation. So if you remember, these are the basic features that we get from an Excel: transpose, paste special. So if you go to an Excel and right, so if, let us say this is my row level data, column level data. If I want to transpose this into a row, so I can do that using my Excel. So I can go and do paste special operation, and in this operation I'll go and select transpose, and what one second. Alright, so I'll copy this again, and from here I'll try to do a paste special, transpose, and click on OK. So what is wrong with this? So it gets transposed to a row level information. Alright, so okay, sure, leave it. So this is an Excel functionality where it gets converted from column to rows and rows to columns. You can do pivot and a reverse pivot transformation. So this is an Excel functionality, and you can use these two functionalities in data services, because at times you might get a requirement to transpose the data from column to rows and work on it again, convert it back from uh, rows to columns and project it to the target system. So let us go and do that with some sample files. I have simple employee sample files, parent child here, not even this one. So I have this, an employee information. So employee number, name, 3-month salary. So I'll transpose this salary columns into rows. So let's go and do it in a job. I call this job underscore pivot and R pivot, since we will be doing both the activities. Sorry, bad throat. Since we'll be doing both the activities within the same this thing. Reverse pivot, then data flow, df underscore pivot. Now I have to connect a flat file here. Skip the row headers as yes. Then it's adapt delimited data. Right, just save and close. Make it as your source, and now you look at the data. So this is your data: 5 records, 5 names, there, 3-month salary. Now go to the Transforms tab, pick the pivot transformation, drag and drop it here, and connect it with your source file. Open this one, and it is divided into 3 areas. One is your schema in, schema out, and pivot columns to rows. So this is a pivot which converts the columns to rows. Sorry, I forgot to show you. So if you look at the graphical representation, you can easily identify that it converts the columns to rows. You can also see that columns to rows here. Now schema in has the input structure, but schema out has a different structure. It has something called sequence number, header, and data. So first thing, I don't want to transpose each and every column into pivot them. So what I do is I drag my columns which I don't want to pivot and pull them here. So these columns will remain same, and only these columns which I want to convert will be dragged and drop into the pivot column box. So the ones I don't want to transpose, I keep them same, and the ones I want to transpose, I drag and drop them here. And you can go and rename this. These are the 3 columns that are created. I'll show you why they are created once I generate this output. So you get one sequence, header, and data. All right. So now you validate your output, and your output is changed. So these 2 columns which I don't want to pivot will be added to my output schema. Now create a template table and call it as pivot, and save it in your target data store. Now if you open this, we are doing pivot, sorry. Validate this one and run the job. So once we get the output, I'll show you what is the sequence, header, and data. Now I converted my 3 columns, right? JSAL, FSAL, and MSAL, all my 3 columns to rows. Now I transpose their data as well. So since they are transposed from columns to rows, so I get a sequence number like 1, 2, 3. How many columns I transpose, I get a sequence number. And if you look at this, the values are repeated thrice, right? Serial number, name, so they are repeated thrice. And here I get the sequence number 1, 2, 3, and I get the SAL, JSAL, FSAL, and MSAL, and their values transposed. So this is how I can transpose this. Instead of applying a business rule on 3 different columns or 5 different columns, I can transpose this into a single column, and I can apply a business rule. I can achieve this one, right? So this is one step. The second one is doing it quite opposite to it, which is converting columns to rows using a reverse pivot transformation. So next data flow, use df underscore r pivot and connect it with your previous transformation, because I want this to be executed, output to be generated, and that output I will use as an input for my reverse pivot transformation. And I will convert it back into a normal structure. So go to the integrator tab, transformations, and select reverse pivot. Connect it with your pivot table. And now you see schema out is empty, schema in has this column. So first thing, pull in the columns that you don't want to be pivoted, right? So non-pivot columns, and then pivot access column is the sequence number. So that is one which gets included, and JSAL, this is one, JSAL, and add it to FSAL, and 3 MSAL. So this is my output columns, my sequence number and their access values and their column prefixes. Now we can drag and drop the header and data into this one, right? So this is what we do. Validate this. Now you see you get these 2 columns which are not transposed in the non-pivot columns. Now we have JSAL header and data, FSAL header and data, MSAL header and data. but we don't need these headers. We need only the data. So you use a query transformation to apply a column level filter, connect it with your previous transformation. Now you pick JCell, data, data. So I'm doing that using a control select. Map to output and do an F2. Copy this. You can do a manual change or go and replace in the output schema where you find this, replace that with null. Replace all, that's done. Now you got here, go back your previous structure. Validate to see if there are any errors. Yes, we have pretty good errors, 3 errors. Now, was not found. Yeah, so that is a mapping problem since we did a rename here. So what I need to do here is map this column to column. Since I did a rename, the connection was lost. So just remap columns. Right, so I have these 3 columns remapped, and now you go and validate. No errors found. Validate all. No errors found. Now I execute this job. So first data flow will transpose the columns, transpose it from column to rows, and the second one will do a reverse transpose where it will convert from rows to columns. So this is how it gets converted initially in the first data flow. But if you go to the second data flow and check the output, we'll have it back in structure, right? So you can do this activity. Now the scenario is like whatever it gets into your project situation. So based on what your scenario demands, if you need to do something like this, right, convert all this columns into rows and then have this calculations done on that, and again you want to put it back into the normal structure, you can go and do that using pivot and reverse pivot transformation. All right, so any questions in the topics that were discussed today? One is data transfer, date generation, effective date, pivot, and reverse pivot transformations. Any questions in this? Please let me know. If not, we'll probably have our next session on Tuesday morning IST. So Saturday and Sunday and Monday, Indian time was holiday. So for US, it is Friday night and Saturday night and Sunday night we have a holiday. So we will have a class again back on Tuesday morning IST, which is Monday night CST. So we'll again catch back. So if you have any questions, please let me know.
Hey Rakesh.
Yeah, Jafar.
Yeah, the pivot one you were showing, you were using the text file, right, as a source?
Yeah.
Okay. What about if we want to use a database table? So how
you can
this?
use anything. You can use anything. I'm just created a sample data so that that will just be very good for us to easily understand. The reason why I created this flat file is just I have a data like this, so I just utilize this one. So if you want to use a database table, so you can use a database table and use it. It is not just limited to a flat file.
Okay. And the second question, when is the requirement comes, like how I would know that we should go with this one? So it will be mentioned in the specification, like a business requirement or something, or maybe I will decide myself when I'm doing some kind of job. So if I see
So
that
we
data.
will. So in a specification, nobody will tell us like go and use this transform, go and use this transform. That will not be there. So it is, our thought which will help us to understand, okay, this is what we need to do and this is what we should not do, right? So let us say there is one scenario where, they have, data spread across multiple columns, right? Column 1, column 2, column 3, column 4, 5. There is some data present there. And you need to apply the same business rule on 5 columns. So you have to do it on 5 columns, the same business rule, right? So in that case, you can transpose that back into one column, all the data into one column, and you can apply a business rule and do a reverse pivot, put it back into the normal structure. You can do that activity. Or uh, so that is one thing. That is one way where you can achieve this activity. So it is not a regularly used transform, but this is a provision
Yeah,
where
it will be very straightforward. Yeah.
yeah, it is not straightforward, or you don't generally need this thing. But just in case you get into a situation where you need this thing, you can
Yeah.
go and achieve this.
Yeah, especially when I'm looking this data integration, all these are different thing, right? So data transfer, data generation, when we will use with the database table, it is challenging, right? So
Yeah,
how?
it will be good. See, the reason why I'm saying with some of the flat files is if I show it on less data, accurate data that we can remember pretty good. So when it gets transposed, it will be easy for you to recall that data. So if I do it on some database table with some, 100 or 250 columns, 250 rows, so you will not even remember like what data is that, how it got transposed. You just see a different in the count. So just to make it very clear, I just put that less number of records. But yeah, you can go
For
and do
example,
that
when you
with
were when you were explaining about the data transfer, it was very straightforward. We can use when we see there is a lot of data coming with the source, and we want to distribute the data flow. And the date generation is little confusion as well, because if we have one column in the database table, we can use the where clause. But if we use this data generation function, it gives us a lot of things like months and functions, right? Effective
yeah,
date.
so this one, yeah, date generation is something, I haven't used in my past 5 years of experience on data migration. I never got an opportunity to use that. I tried my best so that, I will utilize this in at least one project and, try to go and talk about this in my trainings, but I never got an opportunity because, I never, got a scenario close enough for that. But, one of my student who works with NBC, the basketball.
Uh-huh.
Uh, I forgot that name. So he told me that there is a scenario where we could use something similar to this. So they created a projected date in the future for the first quarter, second quarter, and third quarter, divided that weekly, and they have that weekly targets. Week 1 we have to do this, week 2 there. So to project that, they use this kind of transformation. So this kind of scenario where he quickly recalled and said, Rakesh, I think we can utilize it this way, the date
Yeah, the
generation.
same thing that the
But
effective date one is very important. Like if you have promotions, then you can use that one, right? Like from this to days, right? Yeah.
exactly. So if you want to track down a good example, track down an employee's history in an organization. So where he joined, from when to when he was a tester, when to when he was a developer. So if you want to track down to his stages, so you can
Or
do
you
that
can,
effective
you
date.
can
Yeah.
get it right. Yeah,
Yeah.
they are very good, but we need to look it into in depth, right? When you want to use it, right?
Yeah. So one thing, Zafar, as I told you, if you know in and out of these transformations, you can do anything on a data migration project. So these are like something tricky. So this is something like your, polished skills, right? If you want to achieve this, you need to think and say like, if I really need this or not in this scenario,
Yeah,
right?
it's
It's
really
not
tricky. Yeah,
something like,
you are right. Yeah.
yeah, it's tricky that you should go by your decision and say, okay, I will use this transformation which will achieve me this additional activity. So this integrated transformation definitions, it says that these transformation sets allows you to do something that you cannot do using a platform transformation. So that's a very generic definition it has. So if
Oh,
you look
okay.
at
So that's good.
material,
For example, if we are not getting our desired result or the data extraction with the platform transform, then we can use or
go
we
with
can see if the data integration maybe provide some kind of features that we can use it and we can get the desired result,
exactly,
right? Okay.
exactly.
Yeah. Okay. Thank you.
Okay, right. Thanks, F. So next we will see a combination. Hierarchy flattening is an independent transformation that we'll be looking at. The next one we will be looking at history preserving, key generation, and not hierarchy flattening, history preserving, key generation, table comparison, and map operation. Again, map back in our this thing. So this combination along with a query transformation, I'll take you through a scenario which is automated delta mechanism, right? So we have timestamp delta that we can create using a new output column and populating that with the system date. So that is one delta mechanism, and second one is an automated delta. So whenever there is a change, so this data will be captured. Now, for today, we will also look at the CDC operation, and we will call it today just one more transformation, so that tomorrow we can, in the next session, we can look at this, and then we can go with the combination transformations, these three. Along with that, we will also call back these transformations we'll use as a combination and go with the scenario. And after that, we can go to the quality. So let me complete this one today. Map CDC operation. So, sorry, this is job map CDC. So when I say map CDC, so CDC stands for change data capture. So df underscore CDC. So I have employee data like this, right? So initially when this guy joins my company, so he is inserted. So the CDC table, so let me just give you a heads up on the CDC tables. These are, a type of tables, change data capture tables, which will maintain the entire history of the data with an operation code and an index number, right? The order in which they are inserted, and also a operation code which will say if they are inserted, updated, or deleted. But these tables, the change data capture tables, will maintain the entire history. So this is a type of table that we generally find on Oracle systems, CDC tables, we call data captures. Now let us say 1000 employee number, Sam, he joined the organization. So this has become an insert, right? And after that, so let us say this 1000 Syam is promoted to senior manager, and his salary has become somewhere around 40,000, and he is in the same department 10. Now if you look at this data, I see duplicates in my information, right? Same 1000 and 100, I'm tracking my history. So initially he was inserted, then he's updated to senior manager and his salary was hiked. Then after some time, he's deleted from the organization. Now his designation will be senior manager. And he was terminated when his salary was 40,000 and he is from department number 10. So I'm just quoting these three records, 1, 2, and 3. So I maintain my history. Right, with an opcode and this one, the sequence. So the highest of this one is 3.1, and the least of this one is the initial one, right? So these tables are called my CDC tables, and I can handle this kind of data using my change data capture transformation, map CDC transformation. So yeah, let's add this flat file. Right, so let's go to the folder where the file is present, and then the file name, tab separated yes, and skip the row headers as yes. Right, so now you have the data here, save and close. Make it as a source. Now if you look at this transformation, go to the transformations tab, go to view apply default layout because the layout has changed. Go to the transformations tab, select the map CDC operation, drag and drop it into your data flow, connect it with your source. Now if you open this map CDC operation, there's like schema in, schema out, and map CDC operation. So it's very simple one. It has two options here. One is the map sequencing column. The sequencing column is required because it should capture when it is inserted, when it is updated, and when it is deleted. If you don't have that sequencing column, then you will not know what is the order, right? So if it is reinserted or what is that, you don't know. So if it is updated 1, 2, 3 times a particular record, so you should maintain the order in which it is getting updated. If not, you will not know what is the right one. So sequencing column should be your row ID, and then operational column, row operation, is your operation which captures, inserts, updates, and deletes. So the moment I pick these two columns here, those two columns are removed from your schema out. Now sorting, the input is already sorted by the sequence column, right? So that is our understanding. Or if you are passing unsorted data into this particular map operation, map CDC operation, just use a query transformation prior to that, and you sort the data first and then send it to this transformation. Now if you want to do an additional group by on a column, you can do a group by on a department number. You can select and drag and drop it here if you want to, right? Then define columns to be filtered, filter updated rows, right? So if I am doing a filter, an update, right? So inserts, updates, and deletes are my operation codes. So I can specifically apply a filter for updates, right? So let us say if I don't want to capture the updates in department 20, I can say the department number is equal to 20 is my filter, and it will exclude is not equal to 20, and that it will go and exclude that particular department, because inserts anyway they get inserted directly from the source, and deletes, they will be marked as delete, but updates you have a frequent tendency to keep them running again and again. So initially he gets promoted from junior developer to a developer, then to a consultant, then to a senior consultant, then to a lead. So if a guy tends to stay in an organization, he gets promotions, right? So his designation will be changed. So updates happen on the data, but insert and delete happen only once. So that is the reason if you want to apply any filter here, you can go ahead and do that. And CDC table, target data store. So one more thing that you need to keep in mind is your CDC table should be a permanent table. So as of now, just for the job purpose, I am creating it to be a template table, because this data goes into this table with a particular opcode, right? Insert, delete, and all these things. So now, oh, sorry. So now you see only these many records are in the system because only these many records are with inserts since it is done for the first time. So only these records are with inserts. So that is the reason why it is loaded. So initial prior to this map CDC operation, what you need to do is you need to maintain the entire data here in this table. And as they get updated, this map operation will capture these updates and it will push these updates into the target table where it gets updated from one designation to another and one salary to another. So this is how your map CDC transformation works. Just for this demo purpose, I used a template table. So you can do a full load from this to this and then make it permanent and use it there. And then you go and change the values in the source file and just rerun the job. Just open the source file, change the values and rerun the job and see how it is going to affect your target table, right? So this is our map CDC transformation. So I'll just call it a day because I have another class to start in 10 minutes. We'll catch back again on Tuesday morning IST, which will be Monday night CST. So until then, please practice, sort out your questions, send a mail to me if you have any questions, right? I'll try to answer them before next session. If in case you have multiple questions, please send out them at least in the first half of the class. I'll try to clarify them to my best, and then once I clarify them, then we'll proceed with the remaining topics. All right. So thank you guys. Thanks for your time and patience. I really like the way you're looking at this subject, the interest. You are on the right track now. Now you understand this. No need for me to talk about the basics and everything. Now you understand what I speak. Now, to tell you, you are at a position of a senior level consultant who can easily understand the system because, I pick my team members. I go and talk to my senior consultant saying that, okay, guys, leads and senior consultants and say, guys, this is the requirement, this is how we have to do it. So break it into different departments. Oracle, you take care. PODS, this is how, what should be my output. And BO reporting, guys, this is what I need to be displayed in the once the development is done. So these guys can pick easily what I'm talking, right? I'm talking on a very high level, but they can analyze it to a technical levels. Now, with this amount of training that we have done so far, you understand what is what. Now we have further classes wherein we will see how we can utilize what we have learned, right? So when we go with the project orientation, we will see in which phase we utilize what. So that will really help us to, understand where and when we need these things to be placed. So I'll do my best. I'll try my best to make it pretty easy for you. And once this training is done, try to give interviews. That is, the only place where we can go and cross-check what we have learned. So best just practice for a week, end to end, and go and give an interview. And that other person should understand your knowledge level, uh, at least minimum to be in level of a lead consultant, right? So that is what I'm trying to project in this training. So if not, just don't get satisfied with the senior consultant something. Go and rework on this thing, practice again, and project yourselves as a lead consultants on this data migration project. So you can definitely do that because we spoke much about that as well, but at least that is the milestone that I'm setting here. So at least to a level of a lead consultant, we should understand this. So everything is there, recordings are shared. So go through them again and again. If you have any questions, please reach out to me. But I just am aiming at, the knowledge levels on this tool should be at least to a level of a lead consultant, right? So all the best, prepare well in this weekend, have fun, but yeah, just also prepare these classes, go through these recordings. I'm expecting more questions this Monday when we catch up, like Monday US time and Tuesday India time. So as we catch up, I'm expecting more questions. So be prepared. If not, I'll go and ask questions. Just kidding. Right. Happy weekend, guys. Enjoy your weekend. We'll catch up again in the next session. Thank you.